Hi everybody, we're going to do similar triangles today. So remember that from Unit 6, the three ways we can do similar triangles are side, angle, side, where we need one proportion and one set of angles. Or we can do side, 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 where we need two proportions that work. All right, so that's type 1, side, angle, side. Type 2, side, side, side. And then type 3 is angle, angle, where we need two sets of congruent angles. So if you look at number 1 here, we are told that DE is parallel to AC. So DE is parallel to AC. That means this angle at D and this angle at A are corresponding. So I think we're going to have side, angle, side here. Oops. Side, angle, side, because we've got a side and then an angle and then another side. And then we've got a side and an angle and another side. So if we set up that proportion, we're going to do 3 over 6. That's 3 over 6. And this whole thing is 5. So the length on that diagonal is 5 over x. So the 5 goes next to the 3, and the x goes next to the 6. 5 over 6. The other way to write that is 3 over 5. You do the two left sides equals 6 over x. Oh, wait a minute. 5 over this should be an x right here. So we're going to multiply 3 times x or 3 times x and get 3x, and then 6 times 5 or 6 times 5 and get 30. Then you solve that equation, and that is going to be AC, the bottom of that triangle. So x equals whatever this equation equals. Kind of messy there today. All right, so oops. My stylus doesn't want to erase that close to the edge of my screen. Oh, there we go. So we're going to remember side, 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 angle, side, and angle, angle. You're going to need those for the rest of these problems. I think there's only 8 of them, but they are a little more challenging, especially from the parallel lines and the triangle sum, triangle inequality. All right. Really wish I could do the whole circle and erase thing. All right. So if we go down here to number 2, we've got some parallel lines. That's helpful. So we know AB is parallel to CD. Automatically, we can think about that Z, so those two angles, because their alternate interior are congruent. And these two angles, if I make the Z the other direction, this angle and this angle are congruent. I think I'm going to have side, angle, side again. So we're going to work with side, angle, side. So I've got a 3 and then angle C and then a 6. So 3 goes with 6. And then over here on the other side, if 3 goes with 6, then X, and then the angle goes with, oh, and there was a number in there. Was that a 4? Look at my notes and see what that is. It's a 4. So 4 goes with X. So if I do 3 and 6, I do 4 and X, 4 and X. Set those equal. So 3X is going to equal 24. And what is the side length of AB? That answers my question. Solve that inequality, or solve that proportion, and you should be good. Question number 3. I'm going to see if I can make this a little bit bigger, because I think we're going to need a little bit more room for number 3. Let's see. So AB, oops. Doesn't want to give me a pen. There we go. AB is parallel to GD. So AB is parallel to GD. And DF is parallel to BH. So this right here is a parallelogram. This is a 1 and this is a 3. And HC is 10. What is the length of AD? So I've got one triangle here, the GHC triangle. So from G to H is 5. That whole thing is 5, and this whole thing is 10. And then I've got this giant triangle, this ABC triangle, where I'm going to make this length Y for a minute, because I don't know what it is. And I know I'm just looking for that piece of it. So if I look at that whole triangle and make that Y, and 1 plus 10 makes this 11, I can do 5 over 10 equals Y over 11 and cross multiply and get 10Y equals 55, or Y equals 5.5. Oops, 5.5. So if Y, this whole distance, equals 5.5 and this piece of it equals 3, 5.5 minus 3 equals my x. So 5.5 minus 3 is going to equal this part right here, which is your answer. All right, let's find my eraser again. I feel like you're fast forwarding through these parts. Wish I could make this go faster. All right, 3 down. I guess I need my pointer. And triangle ABC is similar to triangle DEF. So AB goes with DE, and BC goes with EF, and AC goes with DF. So we're just going to set up those proportions. I'm going to start with 6 over 9 and 6 over 9. And then I'm going to add in my 5. So the 6 goes with the 5. So I can put a 5 here. And that's going to be x. So we're going to solve that proportion. And then we're going to come over here and do 9 over, we'll make that y. 9 over y. Solve those, cross multiply, 6x equals 45, 6x equals 45, and 6y equals 81. Solve those for x and y, and then make sure that you are solving for the perimeter of this bigger triangle. So once you find x and y, how do you find the perimeter? You got to add them all up. For the next one, so this is a square DBCE. So all of these are 3. And this is a right angle, which means this is a right triangle. And if I know that's a right triangle, I can do Pythagorean theorem. So a squared plus b squared equals c squared. I've got the 2 legs, 3 squared plus 4 squared equals c squared. Hopefully some of you have figured that out this already, that it's going to be a Pythagorean triple. And you don't even need to do all of this math if you recognize that. So many of you probably just wrote 5 right there. So I've got a small triangle here, the 3 and the 4. The shortcut to this is ABD is going to be similar because they're both right angles, and this has the same slope. This COA and BDA, those angles are corresponding. So you've got side angle side going on. So if I'm looking for AD, that's my x. So I've got x over 3, that's the pink triangle on top. And then the orange triangle, the x goes with the 5. And the 3, the 3 here goes with the 4. The 3 goes with the 4. So 4x is going to equal 15. 4x equals 15. Do the division, and that's what you're going to get for AD, and that's just your answer. Erase, erase, erase. Question number 6. These questions have a lot of parts to them. That's what the SAT is really checking for, is to see if you can figure out all of these little pieces and put a lot of different things together all in one question. All right. Pointer tool. Question number 6. Question number 6 is also a square. So I know that's 12, that's 12, that's 12, that's 12. Because this is the hypotenuse, I know that's 12 on the square root of 2, right? So if the whole thing is 12 on the square root of 2 and 12 on the square root of 2 and 12, I can make a ratio out of that. The side over the diagonal. And then I know that in this triangle, I've got a 4, and I'm looking for that piece right there. So if we've got a reflexive angle up there, the 4 goes with the 12, and then x goes down here. Just because we've got that square root of 2 doesn't mean we do anything different. Really, it's just going to be 4 on the square root of 2, because those are going to cancel and be 1 over the square root of 2, which means that's got to be 4. Boom. Don't usually give you your answers, but that is your answer right there, because the blue triangle is similar to the purple one. In question number 7, AB is 12. AC is 13. This is a right triangle, so we can do Pythagorean theorem. A squared plus 12 squared equals 13 squared. This is another Pythagorean triple. If you have this memorized, it will save you a lot of time. But we can do this, 169, and then a squared equals 25, and a equals 5. It's just a lot faster if you can write a 5 right there. So what is the length of AE? I've got BC goes with DE. So I can do 3 over 5. And then AE is what I want to know. AE is the other leg. They make the right angle. So I need this side. So if I'm doing x, the x goes next to the 3 because they're in the same small triangle. And then the 12 is what I need here. So 5x equals 36. Solve that. These look a lot harder than they actually are. The trick to these questions is just start with what you know. Don't worry about thinking about the right way to solve it. Just write out everything you know and see what comes out. You might have a different way of doing it than I do, and that is okay. Those are the kinds of things that I like to discuss when we're actually meeting in the chat room. Erase all of our Pythagorean theorem. I think this is our last question, if I did this correctly. Oh, that was our last question. Great, great, great. Good luck.